Hello and welcome to the lesson on further differentiation. So like usual, let's warm up first. So back to what we've been doing before. So a function g of x is equal to basically x cubed over 3 and so on. We want you to find g of x. So g apostrophe x. In order to do that, you need to find the derivative. You need to find the gradient function. And what you can do, one way to do it is you can think of x cubed over 3 as 1/3 x cubed. You could do that, or you could kind of do what I've done here. So remember, you take the exponent, you multiply it out the front, and then you reduce the power by 2. But don't forget you're still dividing by 3. So take the exponent, multiply by the coefficient, which is 1. 3 times 1 is 3. And then you reduce the exponent by 1. So x squared. It's still over 3. So then 3 over 3 cancels down to give you x squared. Remember, for this one, negative x squared, you take the exponent, you multiply it by the coefficient out the front, and that will give you 2x, and then subtract 1 from the exponent, gives you x to the power of 1, but we don't bother to write the 1 if it's in it, the exponent is 1. Remember, we've got an x term, so what comes, that's negative 1x, so therefore when you differentiate that, the x just disappears, negative 1, and this is the constant term, and that just disappears. It becomes like plus 0. So then, as we said, this one cancels down to give you x squared. Then you're asked to solve g dash of x equals negative 2. So take the function you've got here, find g, which you've got the gradient function, set it equal to negative 2. That'll get you a method mark just for doing that, because they want the gradient function set equal to negative 2, not the original function. And then what you're required to do is solve that. And I would look at this and go, this looks like a quadratic equation. Maybe I need to use polysmalt or something like that. But before you solve a quadratic equation, remember you've got to have it set equal to 0 first. So we've got to deal with this negative 2, therefore we need to add 2 over here. So we need to add 2 to both sides so that this cancels out to give you 0. So negative 1 plus 2, if you're not sure, do it in the calculator. It should give you positive 1. And then x squared minus 2x plus 1 equals 0. This is when you could factorize, like two numbers that multiply to give positive 1 and add to give negative 2 are minus 1 and minus 1. I'll also remind you how you can use polysmalt to solve this quadratic as well. Maybe you go apps. It's a good thing to remember for your exams. Number 4, polysmalt, whatever polysmalt number is for yours. Poly root finder, so select the first one. We should have set up like this, just basically order of 2. We need to click on next, and remember the coefficient of the x squared term goes here, and there's nothing there, so that means 1, because it's 1x squared, of course. The coefficient of the x term has to come next, so in this case it's a negative 2, and the constant term has to come last. In this case it's a negative 1. So I'm using negative 1, not minus 1, and then click solve. Oops, I've got a different answer. So I must have put in something wrong in my coefficients. Let's see, what did I do wrong? Okay, no, it's all okay. Oh, sorry, no, it's plus 1. The constant term, sorry, I was looking at the top part here, but when we add 2 to both sides, we get plus 1. So I should have positive 1 here. So I should clear that. 1, solve. There you go. So x equals 1, x equals 1. Because x minus 1 is 0. So therefore, if x minus 1 is 0, x must be equal to positive 1, because 1 minus 1 is 0. Plus also you got it on polysmalt. So there was one answer there. Now we just need to scroll down. Calculate the values of g dash of x when x equals negative 1. These are the nice easy ones. They want you to just sub the x into the gradient function. So don't take the original function by mistake. People can tend to do that. Take the gradient function, and then take the gradient function, and you need to substitute in x equals negative 1. So here's the gradient function here, but with the x is replaced with negative 1s in brackets. I can go into the calculator just like that, and you can go straight from this. You need to show this step, and you can go straight to the answer if you want, or you could try to work something out in the middle. I tend to enter it straight into the calculator like this these days and just work out the answer, but make sure you show that step. Same thing again, but when x equals 0, so you've got the gradient function, sorry, which is not that one. Make sure to use this one, gradient function. And we substitute in x equals 0. So put the zeros in brackets, plug it in the calculator like this, and you get negative 1. Hence state whether the function is increasing or decreasing at x equals -1 and x equals 0. So notice these are referring to your answers. So try to think if it's increasing, if the function's increasing, like going up, remember the gradient's positive. If it's decreasing, it's going down, so the gradient's negative. So let's look at x equals -1. Is the gradient positive or negative? It's negative, therefore it's decreasing. And write a reason as the gradient is -2 is what that says. Decreasing as gradient is -2 as opposed to a positive value. At x equals 0, what is the value of the gradient? It's negative again. So at this point, the function is decreasing because the gradient is a negative value. Okay, so out of the warm-up now, onto further differentiation. So this is a big practice of a lot of more difficult differentiation, basically. So differentiating can be a little tricky if you have x terms in the denominator, like this. So you've got x terms not on the top, but you've got them in the denominator, an x term here. Below it is a worked example, which has been worked out for you step by step. So this has actually been worked out for you, but I'll just talk you through it. So there's a left-hand problem in blue and the right-hand problem in black over here. So let's do the left-hand problem first. Okay, so find the gradient function of the following. So we're doing question A, and then I'll go through question B with you. Here's the gradient, here's the original function, and notice what's awkward, and it's appearing more and more in exams these days where you have x's in the denominator, which can be awkward. So as I've said, the first step before you even begin to do the calculus and to find the gradient function is to do what I call flattening the function, which is basically getting the getting the x's out of the denominator by bringing them up higher. To do this, you may need to break up the numerator. So in this case, this one would be an example where we'd have to break up the numerator. See how I did it here, 4x over x, but we'll deal with that when we get to it. If it's not already broken up, here the numerator has been broken up already. It's not all chunked together like that. You can't break up the denominator though. A is already broken up, which is fine. So but B has to have its numerator broken up first, but this one's already broken up, so let's move on to the next step. So this is a step where I just break up the numerator on that one, but this one's already broken up. Notice that you can cancel down some x's in B, but it will deal with B later, I keep forgetting. So this one. So now what we have is the original function still. So this is still the original blue function. So before you even do the calculus, you've got to bring these x's up into the numerator, unfortunately, before you can do the calculus step. So to bring the x's up, it's back to like your index laws. Do you remember like 1 over x is the same as x to the power of -1, or 1 over x squared is the same as x to the power of -2? If you've forgotten that, that's fine. Just accept it that that's the case. So the way you can bring this x squared up into the numerator is you turn it into, bring it up here and call it x to the power of -2. So you make the exponent negative. So that's what this step's trying to point out. We're going to bring that up and make it 3x to the power of -2. We're going to bring this one up and make that 1x to the power of -3. And this one's already fine, it's just minus x. So see, I've done that here, 3x to the power of -2. The exponent wants to bring it back up. It becomes a negative exponent. X to the -3 here. So basically it changes sign. If it was positive down here, it comes up and it becomes negative. Minus x. So, and because that's 1x to the -3, I just don't bother to write the coefficient of 1. Now you have, so notice it's flattened. So it actually looks like, compared with this version, it looks like a flattened function. That's why I call this step flattening the function first, which you only do if there's x's in the denominator. Now that you flatten the function, you can just do the calculus like normal. So if you've got y equals, then to find the gradient function, which if it's y equals, it would be dy dx equals, and remember you multiply the exponent by the coefficient. What's -2 multiplied by 3? If you think about it, that's right, it would be -6. And then you need to subtract 1 from the exponent, like we do when we do the calculus. So what's -2 minus 1? If you're not sure, put it in a calculator, and it would be -3. Don't forget to write the x. Lots of people miss out on the x. So that's -6x to the power of -3. Same thing here, that's like a 1x. So -3 times 1 gives you -3 is the new coefficient. X to the power of, what would be this minus 1? It would be -4. So that makes negative 3 x to the negative 4. And remember, that's just 1x, and if it's an x function, you just drop off the x. And there's no constant term, so nothing to disappear off anyway. So that's 1x, so x, that becomes 1 when you differentiate it. So what's on, like, this is normally completely fine for your final answer, but they might say that you need to write your final answer with positive indices, so no negative indices. So what you can do, if that's unusual, but they might say prove that this becomes that, and I can let you know that the reason why this is the same thing as that is because you can do the reverse step. Remember how you can bring this up and you just change the sign on the exponent, you make it x to the negative 2. Same thing, you can bring the x down again and you just make the exponent the opposite sign of what you've got here. So negative 6 stays on the top, bring the x down by making it x cubed instead of x to the negative 3. Same thing with this, make it negative 3 on the top. You can have the negative 3 up here or you can have it down there, it doesn't matter. To bring the x down to the bottom, make the by making it x to the power of positive 4. So notice the indices are now positive and you've still got minus 1 there. So I've just pointed out here that you could negative 6 over x cubed. It's not wrong if you wrote it as a negative out the front. Negative 6 over x cubed, it's the same thing. And same thing with that, you could have written this as negative 3 over x to the 4, or you can put the negative there. This is probably, to be honest, this is probably how they'll write the answers. And therefore, that's the gradient function for that one. Here's another more complicated one, as I said. So in this case, the numerator was broken up, but here the numerator is all chunked together. So your first step is to break up the numerator. You're not allowed to break up a denominator, but you're allowed to break up a numerator. So this becomes 4x4 over x, which we write like this, 5x squared over x, which we write like this, 3x, negative 3x over x, which we write like that, and negative 2 over x. And now see if you can do any cancelling down. So see, you've got x to the 4 over x, so you agree that that will cancel down to x cubed. So we can rewrite this as 4x cubed. X squared over x cancels down to just give you x. So we can rewrite this as 5x. 3x over x, the x's completely cancel each other out in this fraction, so it just becomes minus 3. And there's no x on the top to cancel down that one, so you're left with negative 2 over x. So rewriting this, 4x cubed plus 5x minus 3. But now we've got to deal with this x down here. We've got to still flatten the function. So we haven't even done the calculus step yet. We're just still flattening the function. So to flatten this function, that's x to the power of positive 1. So to bring it up to the top, you would have to make it negative minus 2x to the power of negative 1. See it like that, because that's x to the positive 1. To bring it up here, you need to change the sign on the exponent. So now this function is now been flattened. So it's nicely flattened, and now we can do the calculus step. So same thing, 4x cubed plus 5x minus 3 minus 2x to the negative 1, power of negative 1. Now let's do the calculus. Let's find, so that's, notice that this was still f of x. So now when you do the calculus step, it's f dash of x. So f dash of x, take the exponent multiplied by the coefficient would give you 12. And then x, don't forget to write the x, people tend to forget that. And then you need to subtract 1 from the exponent, and you've got 2. This is 5x to the 1, so 1 times 5 is just 5, and then x to the 0 is just 1. So again, sorry, remember 5x just becomes 5. Constant terms, they just become 0, so it floats away, so ignore it. But you've got negative 2x to the negative 1 here. What's negative 1 multiplied by negative 2? That's right, it's positive 2. And don't forget to write the x. And the new exponent, remember, is 1 less than the previous. So negative 1 minus 1 is negative 2. So this is your gradient function. If they wanted, like this normally is fine for an answer, but for some reason if they wanted you to express it like this or with positive indices, you've got a positive indice here, so no problem, positive exponent. Just 1 second. Yeah, so if you're asked to express this with positive indices, as I said, 12x squared is positive already. 5, it's just still, there's no indices, so you just write 5. But this one's got negative indices, so try to think, how do you make it a positive index? You leave the 2 on the top, and you take the x and bring it down, and make the exponent positive. The change, when you bring it down, change a sign. When you bring it up, it changes sign. Yeah, and so that's how, this is a fine answer unless they ask for it expressed with positive indices, or they might, the question might be show that it can be expressed like this. So you just have to be aware that that can be turned into this by taking the x, bringing it down, and changing the sign on the exponent. Pretty complicated stuff, so let's do some more practice of it. Okay, differentiate the following. Don't forget to flatten first if necessary. So I've given you ones that need to be flattened. This one's already got a broken up numerator. This one needs to be broken up first. So we can go straight to flattening. This part's already flattened. That's all nice. But minus 4 over x, this is x to the 1. So bring the x up here and make it x to the negative 1. See that? Still the negative here. 4x to the negative 1. And a plus. This is x to the positive 3. So bring it up and make it x to the negative 3. So plus 3x to the negative 3. Congratulations, you have flattened the function. Now you do the calculus step. So that's still the original function, fx. So the calculus, the gradient function will be f dash x. So make sure to write f dash x equals. Remember, x terms just become the number, 7. Here you multiply the exponent by the coefficient to make positive 4, and subtract 1 from the exponent. Gives you negative 2. Don't forget to write the x. Negative 3 multiplied by 3 is negative 9, x to the power of negative 4. Awesome, totally fine answer this one, unless they ask for positive indices, as I said, which you can rewrite like that. But this is fine if they don't. If they don't bother asking for positive indices, no need to turn it into this version at all. Here's another one where the numerator needs to be broken up first. So before we even flatten, break up the numerator, make it x squared over x plus 4x over x minus 5 over x. And then I've started to cancel down. X squared over x just cancels down to give you x. 4x over x, the two x's cancel down to give you plus 4. And you've got minus 5 over x. So that becomes x plus 4 minus 5 over x. And remember, you can make this flatten it by making it 5x to the negative 1 instead of positive 1. So minus 5x to the negative 1. Congratulations, you have flattened the function. And now you need to do the calculus step. So here's the original function, f of x. The calculus function will be f dash x. So remember, this is 1x. So it just, in the gradient function, it just becomes 1. Plus 4 is a constant term, so it floats away, becomes 0. It's not there anymore, basically. Minus 1, oh, sorry, what am I saying here? Yeah, negative 1 times negative 5 gives you positive 5. X to the power of negative 2, because you subtract 1. This is totally fine for an answer. If for some reason you're required to give positive indices, remember you can take the negative index and bring it down. It makes the exponent positive now. Next, do some more practice. You're welcome to, if you want to, pause and just try these yourself, and then feel free to have a look through. I'll very quickly talk you through them. This one needs a numerator broken up first, so change it to 2x over x squared minus 3 over x squared. Cancel down if possible. So you can cancel an x from here and an x from here, which makes it 2 over x. There's no x here to cancel there, so you just leave it as 3 over x squared. 2 over x, to flatten it, you make it 2. That's 2 over x to the 1, so make it 2 multiplied by x to the negative 1. Minus 3x, bring it up by making it to the negative 2. That's the original function, so your calculus function will be f dash of x equals negative 2x to the power of negative 2 when you subtract 1. Negative 2 times negative 3 is positive 6. So x, subtract 1, you get negative 3. Perfect answer, unless you need positive exponents, in which case these negative exponents need to come down and be made positive. Notice, see, the 6 stays at the top, but it's just the x that comes down and its exponent becomes positive. Same thing, you need to break up the numerator. This becomes x cubed over x plus 5 over x. Cancel down if you can. X cubed over x cancels down to x squared. This one doesn't cancel down, but now you can flatten it. So x squared plus 5x, this is x to the 1, so bring it up and make it x to the negative 1. Here's the original function. Now do the calculus. F dash of x becomes, that's 1, so 2 times 1 is 2, x to the power of 1, so you don't need to write the 1 though. Negative 1 times 5 is negative 5, x to the power of, subtract 1, negative 2. If you need to, perfect answer, if you need to make it positive indices, just bring it down like that. Same thing again, x cubed over x plus x over x minus 3 over x. X cubed over x cancels down to give you x squared. X divided by x just cancels to give you 1, and that's minus 3 over x. So you've got x squared plus 1, and then flatten this part, bring the that's x to the 1, bring it up and make it x to the negative 1. Original function, now do the calculus. That becomes 2x to the power of 1. Constant function floats away. It becomes positive 3x to the power of negative 2. If you need to write this as positive indices, you just take this and bring it down and make that a positive x squared. Again, there's more and more questions appearing in exams these days where you have to break up the numerator, or you have to cancel down x's, for example, or flatten the function first. That's why I'm giving you lots of practice in this lesson of that. Here's another example. Find the gradient function, basically do the calculus of this original function, x squared minus 4 over x. So you've got an x in the denominator. Numerator is already broken up, yay. And hence find the gradient of the tangent to the function at the point where x equals 2. Find the gradient of the tangent to the function just means that find the gradient function and plug in x equals 2. The tangent is just a line that represents the gradient at a particular point. So basically it's just asking you to find the gradient function and then substitute in x equals 2 to calculate the gradient. In a later lesson you learn more about tangents in detail. So first step, here's the original function. You've got to flatten it. X squared's already flattened. Change this one, that's x to the 1, so change it to minus 4x to the power of negative 1. Original function here, now you're going to do the calculus because it's been flattened. F dash of x equals, that becomes 2 times 1 is 2, x to the power of positive 1. Negative 1 times negative 4 is positive 4, x, subtract 1 to the power of negative 2. If you need to express it with positive indices, then you can just take this and bring it down. But if not, you can leave it like that. So now to find the gradient at x equals 2, just plug in into this one or this one, plug in x equals 2. So you could, if I'm plugging into this one, I'd go 2 brackets 2 plus 4 over 2 squared, plug it in the calculator, work out the answer, and we get 5. You could also, in the calculator, plug it into, where is it, this version. Just not into the original, plug it into the gradient function, because you're fine calculating the gradient. 2 times 2, 2 brackets 2, plus 4 brackets 2 to the negative 2. Plug it into the calculator, you'll get 5 as well. Just make sure to show the substitution step. Oops, okay, sorry, back to here, some more practice. Find the gradient of the tangent to y equals x squared at x equals 2. Just practicing, these aren't flattening, this isn't the flattening one, but it's still good just to practice a regular one. So find the gradient of the tangent means find the gradient function and then plug in x equals 2, whatever the x value is they give you. So you've got y equals x squared, so we write, instead of f, you could write f dash of x, but you can also write dy dx. It's good to get used to all the terminology that could be presented to you. It means the same thing as f dash x. Basically it's a gradient function. So 2, that's 1x squared, so 2 times 1 is 2, x, and then subtract 1 gives you x to the 1, and just plug in 2. 2 brackets 2 equals 4. Here's one that we have to flatten first, so take the x squared, bring it up here and make it x to the minus 2. So we've still got the original function, so it's still just y equals 8x to the negative 2. Now find the gradient function, dy dx equals negative 2 times 8, negative 16x. Subtract 1 from here, you get negative 3. So you've found the gradient function, great. Now you need to just find what it equals when x equals 9. So the gradient when x equals 9, you just plug it in, negative 16 brackets 9 to the negative 3. This can go into the calculator, no problem, and you get this rounded to 3 sig figs, or you could math fraction. If you're not sure about your rounding to 3 sig figs, you can always math fraction it and get the correct answer here. By math fraction, I mean on the graphing calculator. You just press math and then fraction. Here's some more. Nice regular flattened one, no issues there. So here's the original function y equals, so the gradient function will be dy dx equals, multiply here, 4x to the 1, minus 3, and the constant term's gone, forget about it. Now just plug in 1. Plug in 1, calculate the answer, negative 7. This one's got a negative exponent, but that's fine, it's been flattened already. So go straight to dy dx equals, find the gradient function. X terms just become the coefficient, 2. Negative times a negative is a positive 5. Subtract 1 from the exponent, negative 2. Then calculate, show the substitution step where you plug in the x value they give you and just get the answer on the calculator. Feel free to try these ones first. This one requires breaking up the numerator first. So break up the numerator in the original function. Notice we're not even doing anything to do with calculus yet. We're just doing the calculus down here later. So y equals, write x squared over x squared minus 4 over x squared. And then I've cancelled down. X squared over x squared just becomes 1. So equals 1 plus, and then flatten this by bringing this up. Plus 4x to the negative 2. Now do the calculus step. Find the gradient. That's the original function. Find the gradient function dy dx equals. That's a constant, so forget about it, disappears. But negative 2 times positive 4, negative 8. X to the power of, subtract 1, negative 3. Now you've got to plug in 4, so write negative 8 brackets 4 to the negative 3. Plug it in the calculator. To 3 sig figs you get this, or a good idea is to press math fraction and just get the fraction answer as well. Another one we have to break up the numerator, so write it as x cubed over x squared minus 4x over x squared minus 8 over x squared. X cubed over x squared cancels down to give you x. 4x over x squared, you can cancel 1x from the top and 1x from the bottom, gives you 4 over x. And you can't cancel down here because there's no x on the top. So now you can just rewrite that one as x. You can flatten 4 over x by making it 4x to the negative 1. And have I made a boo-boo here? Like there's a minus here, but why do I suddenly have a plus? That's a bit of a boo-boo on my side. So sorry about that. You should have, let's see if I can fix it. That should be a minus here because there's not been any calculus done. So sorry about that. That should stay as 4 over x. So it becomes minus 4x to the minus 1. Minus, flatten this part by bringing the x squared up and making the exponent negative. Negative 8x to the negative 2. So now I might have to change this. So dy dx, now that's the original function. Now let's do the gradient function. Dy dx equals, that's 1x, so it just becomes 1. Negative 1 multiplied by negative 4 is positive 4. So I should have a positive here, sorry. So positive 4x, subtract 1, you get negative 2. And that's negative 2 times negative 8 plus 16, x to the power of negative 3. And now you can just plug in what x equals negative 1, but I should have a plus there instead. So the answer might not be negative 11 anymore. Let's check it on calculator. Good thing to practice putting it in calculator. Second quit. Okay, so it's going to be 1. We're substituting in negative 1. So 1 plus is what I've got now. 4 brackets negative 1 all to the power of negative 2. Then you might need to arrow out of that. Plus 16 brackets negative 1 all to the power of negative 3. So always look at it, see, have I got the right things in there? Did I put in plus 1 by mistake? No, I put in negative 1. Lovely. So our answer, what is it now? It is negative 11. Okay, so I must have calculated the answer right, but I just had the wrong step there. Great. So just be aware that's a negative there and positives here instead. So I probably need to just quickly save that before I forget this and let it go. Oh dear, sorry. Okay, that's just checking. Yep, last page. Okay, so here's some more questions. If y equals 4x minus 3 over x, find dy dx, so basically find the gradient function and interpret its meaning. So first step, flatten the function because it's not flattened yet, so it's the original function, so don't call it dy dx, call it y equals still. So 4x is fine, that's been flattened. This is x to the power of positive 1, so change it to x, bring it up here and make it x to the power of negative 1. So minus 3 x to the power of negative 1. Congratulations, it's been flattened. Now we can do the calculus step. So if it's y equals, change it to dy dx to do the gradient function. An x term just becomes a coefficient, 4x becomes 4. Negative 1 multiplied by negative 3 becomes positive 3x. New exponent by subtracting 1 is negative 2. And you are asked to interpret its meaning. What is it? This is the function which represents the gradient of the original function. That's all I could think to say. So this gradient function, it's a function which represents the gradient. There's been something here and there in an exam where you are expected to just realize that. Obviously we call it the gradient function because it represents It's a function that you can use to calculate the gradient of the original function at any point value of x. Same thing, let's go on to a new one. So the position of a car moving along a straight road is given by s equals 2t squared plus 4t in meters. So meters isn't part of it, it's just the units. So ignore it if that's confusing you. Where t is the time in seconds. Find the s dt. It's like saying dy dx and interpret its meaning. It's just because instead of y and x, we've got s and t. That's why they say ds dt. So they want you to do the gradient, find the gradient function of this and interpret its meaning. So the original function is s, the gradient function will be ds dt, and 2 times 2 is 4, and then t to the power, subtract 1 from the exponent, t to the power of 1, which we don't bother to write, plus 4t is like saying 4x, so therefore 4x would just become 4. What is this? It's talking about speed, or is it? Oh no, sorry, this is the position of the graph. And so I'm not sure if you've done stuff about like distance, velocity, like speed and acceleration, but if you haven't, that's fine. So basically, if this is the speed function, if this is the distance function, this would be the rate of change of distance with time. So it's talking about the change in distance over the change in time. Remember, change in distance over change in time, it's the speed of the car. If it was change in speed over time, that would be the acceleration of the car. So this is a function that represents the speed of the car at any given point in time. Here's the last one. It's good to just apply it to some real world stuff. So the cost of producing and selling X toasters each week is given by the cost function in terms of X dollars. Find the CDX and interpret its meaning. So basically find the gradient. So this is a constant, so it just disappears. Plus 3x just becomes 3. And 2 times 0.002 in the calculator is 0.004. That becomes x to the power of 1. What does it mean? It's a function that represents the cost per week of producing and selling toasters at any given amount of toasters. Okay, and that's the end of the lesson.